Hello and welcome to Routing, a part of the Building APIs with ASP.NET Core course. In this module, we'll discuss how to build route architectures for your applications and then how to apply those designs within ASP.NET. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you how to build APIs with ASP.NET Core. In this module, we'll discuss URL design. As your application grows, having a solid plan for how future API endpoints should be added will help you immensely. Next, we'll learn how to take our URLs and build them out in ASP.NET Core using several different methods. Finally, we'll learn how to extract data out of our routes with parameters and how to design for more complex routes with nesting. In this module, we'll cover aspects of URL design that you should be aware of before building your applications. It is important to think about the structure of your URLs when designing your APIs. The most important reason for this is that your paths are a critical part of expressing the intent of a request. For example, a request to get API/products, the intent is to get a list of products. And likewise, a request to post API/products, the intent is to create a new product. But the URL structure can get a little bit more complicated as you start to pile on layers. Imagine a scenario where you're building an API to serve up simple geographical data about the United States. You need to be able to serve data about states and cities. What does a request to get a list of states look like? Well, it's pretty straightforward. As a human, you understand exactly what's going to happen when you make a call to get states. Well, let's talk about nested routes a bit. Get states returns a list of states, but probably only going to return basic information about each state. What if you want to get more detailed information about a particular state? One way we could design our URLs is to accept parameters. So for example, get states/VA or Virginia. The URL structure lets us be more specific about our request and retrieves detailed information about that particular state. And while having details about a state is useful, our next goal is to be able to get a list of cities for any particular state. We can continue adding to our URL structure, and we can append another section to request the cities for that state. The intent is very clear. Get all the cities in Virginia. Now, by now, you should be seeing the pattern for our URLs. As you learn more about your application's domain, these URLs will start to build themselves naturally. Here's another example of a natural progression of our URL structure. Assume that after we've launched our API with state and city geographical data, a request comes in for us to provide metadata about state parks within the United States. Since we've already defined a path for getting state information, what if we built on that format by giving us state park information for any given state? The pattern fits perfectly. In this module, we'll discuss various ways we can define our routes within ASP.NET Core. There are two methods for defining routes in ASP.NET Core: convention or configuration. Convention was a popular method for ASP.NET MVC applications many years ago. Convention is defined in a process where you tell ASP.NET about controller routes and the URL pattern it's matching against. This example, we're telling ASP.NET Core a couple things. First, we're giving our route the name of default. Although we can call it anything we want to. The name doesn't matter, but it can be used in the future to define URLs for linking purposes. Second, we're defining a pattern for the route. The curly brackets represent a parameter or a placeholder for the potential future URL. ASP.NET Core uses the values of these parameters to determine where a request should go. A sample request hitting against this route configuration would be parsed as so. The first parameter is the controller. ASP.NET is pretty smart here. It will automatically append controller to the end of controller names, and then it searches for a controller matching that name. So state controller is found. The second parameter is the action, and this is a one-to-one translation between what's in the URL and what the method name in ASP.NET looks like. Ensure your methods are named in a way you expect ASP.NET to find them. You might notice there's an ID at the end of the pattern with a question mark. And this defines an optional route parameter called ID. It's not required, but if it were, the ID would be extracted from the route and passed in as a parameter to the action being called. And under the pattern, we have a list of defaults. These are commonly used if the pattern is missing some information. For example, if a route's missing an action, but it has a controller defined, it will automatically assume the index action should be used. As you might see in previous examples, convention is more likely useful for MVC or view rendering based applications. Our API definitions would be pretty robust if we were to build them out in this manner and make it more difficult to debug. Another option, configuration, is a better alternative as you start building APIs, especially with ASP.NET Core. With this approach, you're defining the intent on the individual controllers and actions that would be affected. Configuration is done via attributes on controller actions. In this example, we're setting two attributes on the action called getStates. The route attribute defines what route pattern the action should respond to. If a client makes a request to our server by going to the states endpoint, that will trigger the getStates action. By default, any controller action will respond to any HTTP verb thrown at it as long as the path matches. But it's possible to tightly define this in your configuration. The HTTP get attribute tells ASP.NET Core that this method will only respond to HTTP get methods. Here's a similar example, but this time we're using the HTTP post attribute. We want to ensure that this action only responds to HTTP post requests to the provided path. The HTTP verb attributes also accept route patterns, so you only need to write one attribute instead of two. If you have an HTTP endpoint that should respond to multiple request types, you can also stack route patterns. The example here will respond to an HTTP post request to states and also an HTTP post request to v1/states. This approach works for 6 different verbs: get, post, put, delete, and patch. Then there's a 6th option for head. We haven't discussed head in detail, but a head request is similar to a get request, with the expectation that the head request should not return a response body. Some clients use head to determine if an endpoint exists. Some clients use it to determine if it should call the get request version of the endpoint. For example, if the get request returns a large object, the client might want to know how big that response is before making the request. In this demo, we'll explore the variety of options for defining routes in ASP.NET Core. For this demo, we want to walk through a very simple scenario of setting up route configuration for an existing controller. When you jump into an ASP.NET Core application that's fresh out of the box, you're going to be presented with a startup CS file that looks very similar to this one. A couple key differences: I've already taken the liberty of setting up dependency injection for a product repository, and I've removed some of the sample code around pre-existing demo routes. The first thing we have to do to turn on controller mapping is within our use endpoints method call. And if you don't have this, you can just add it. So that I need to tell ASP.NET Core that I intend to use controllers and that it should map the controllers for me. So under configure, I simply say endpoints.map controllers. This will tell ASP.NET Core to search all my existing controllers and look at their route definitions and create a route table internally so it knows how to map any incoming connections. In order to use map controllers efficiently, you have to also add the dependency injection. So up in configure services, we'll add services, add controllers, and that will prevent us from having any runtime errors. I've already taken the liberty of creating a products controller, and here's the sample. It inherits from controller base because we don't need any view logic. It injects an iProduct repository because, again, we don't care where our products are coming from. We're just in development mode, and we know that we need to get a list of products and also potentially create products in the future. I've created two methods, get products and then create product, to represent some of the common examples that you'll see when building your own APIs. Now, I haven't already created the route definitions for either of these methods. So if I were to run this application, nothing would work because there are no routes defined in ASP.NET Core's internal route table. Let's start with get products. For get products, I need to tell it that I want to respond to a GET request to /products. There's a couple ways I can do this. First, I can define the route attribute and tell it that I want to respond to the products endpoint. Even though I'm not designating this, ASP.NET Core will respond to any HTTP verb in this case. If I were to send a HTTP post request to /products, this method would still respond to it. It's common in your APIs to designate which HTTP verbs should be used in a variety of cases. So here I am telling ASP.NET Core I want an HTTP GET request to /products to be the only endpoint that can cause this method to get triggered. Well, let's walk through an example of running this inside of Postman. Over in Postman, I have set up my URL that should respond to this particular request, and I'll hit send. This goes off to my API. You can see it returns a response at 200 OK. We can walk through this process and see that when we make that call to get products, it hits the breakpoint that I've set under get products, and I can step into my product repository, and my internal product repository, which I've just called fake product repository, will return a static list of products. Next, let's take a look at the post products endpoint. And this is typically used when our intent is to create a new product. And we're going to design this a little bit differently than we did before. In the get products example, I had a route attribute and the HTTP verb attribute. But sometimes it can get a little tedious just writing all that code. What if we just wrote HTTP post and told it, I want you to respond to /products. Your eye will probably be drawn to the fact that we're using the same endpoint for both of these methods, or both of these actions. The differentiator is going to be the HTTP GET versus the HTTP POST. And ASP.NET Core is smart enough to understand the differences between the two. In this POST request, we're going to send in POST data, which will get sent to our product repository, and a new product will get generated. Now, part of creating a new product, or any new entity for that matter, you should return not just a 200 OK, you should return a 201 created. ASP.NET Core has helper methods for you to send back these responses, but to properly format a creative response, you have to not just send back an instance of the product you had created, you should also send back a URL that would help ASP.NET Core go get more information about that product in the future. Let's go ahead and run this example in Postman and see what happens. Back over in Postman, I have recreated the request to /products, but I've changed the HTTP verb to post because I want to send data up. And inside of Postman, I need to tell it what data to send. So I've populated the request body for this request. And I've told Postman that this is going to get sent as JSON. This JSON body provides the two properties that we need for a product. And when I hit send, we'll hit the breakpoint in our backend. And one thing you'll notice is that my product is not properly binding. That's because I've skipped or missed a couple steps. Now let's fix this issue so we're making sure that we're getting the right data back in our request. Because this is an API controller, I should map API controller. By doing this, ASP.NET Core will give me a little bit of a helping hand by instituting some model binding techniques to ensure that this product coming in actually has the data that I expect it to. Let's rerun this example. I'm going to hit send. We'll hit our breakpoint one more time. And if we look at the new product, we'll see it is actually populating with the contents of the request body that we're sending in. Now, I said before, we need to return a 201 created whenever we create a new entity. You don't necessarily have to do this. It's just a good technique when you're trying to follow REST standards. Major part of a 201 is that you have to populate the location header of the response. And ASP.NET Core will do that for you automatically if you use the created response type. But we need to generate the URL for this new created object, which would most likely be products/1 or the ID. Now we don't have that action yet. We're going to do that in the next demo, but it's a good practice for us to create that now so it's ready for us to use next time. And then I'll return created by passing in that URL and also the object that we just generated. ASP.NET Core will automatically turn this into JSON and send it back as a response. And finally, over in Postman, we can see the results. We returned our 201 created, and we can see the new product that got sent. Has an ID of 1, a name, and a description. If we head over to the headers, we'll see there's also a location header that's been added that tells us the URL we should use to get more information about this product in the future, or if we wanted to get the information about this product in particular. So to recap, when you're designating route configuration inside of your APIs, it's a good practice to use either a combination of the route attribute and an HTTP verb attribute, or you could just use an HTTP verb attribute by itself. Either way works. In this section, we'll define route patterns and building out nested routes. Let's revisit an earlier example. We mentioned that you can add placeholders or parameters to any route definition. When ASP.NET Core detects a route matching your pattern, the parameters will automatically be parsed out of the route and passed into your method call. Ensure the names of the parameters match, and this is one less thing you'll need to worry about. We can add constraints to any route parameters. And these constraints ensure that the parameter inputs you receive are valid and of the type that you're expecting. For example, this route definition ensures that the ID we receive is of the type int. If a client were to send a request using alphabetical characters, this would be rejected by ASP.NET Core. And there are several types of constraints available to you. In these examples, we're setting min or max constraints on the ID. ASP.NET Core will ensure that the route matches will only occur if these rules are satisfied. And in case you're wondering, it's possible to combine constraints together. Using a colon as a delimiter, you can stack as many constraints on a route parameter as you want. This ensures that our ID is an integer and it's between the values of 1 and 1000. The URL on the screen will link you to all the possible route constraints built into ASP.NET Core. Also important, Do not use route constraints for input validation, as tempting as that might be. The big reason is that when a route constraint isn't met, it will return a 404 not found. In the case of input validation, you shouldn't return that. You should return a 400 bad request because it provides the clients that make the request more information about how the request they made was incorrect. We'll discuss input validation more in depth in another module. As you build larger, more complex API controllers, there are a couple tricks you can use to minimize the amount of typing that you have to do. On this example, we have two actions whose routes start with states. If you're maintaining consistency with your URL design, it's likely that any future actions in this controller will start with states as well. And there's a trick we can use to define nested routes, or routes that share a common prefix. If you define the route attribute on the individual controller, ASP.NET Core will use that as a prefix for child actions. Using this pattern will also allow you to make changes across the board to that route pattern if you need to in the future. In this demo, we'll explore new tricks we've learned with route parameters and nested routes. In a previous demo, we walked through the process of creating and setting up routes and HTTP verbs to ensure that ASP.NET Core knows how to translate the intent of a given request into a method call. What we'd like to do in this demo is expand on our previous example just a little bit and create a new method that takes a parameter. If you recall from our previous example, we created a URL that points to a newly created product. This URL could be used to get more details in the future. Now let's go create the action that returns a result based off that URL. For our purposes, this is going to be a GET request to products/some ID. So for example, 1 or 2. It could be a GUID. It could be a unique string. We'll scaffold out our getProductById method, and then we'll go set up the HTTP GET request to products/some ID. The ID is in curly brackets. That designates that we're inserting a parameter. When ASP.NET Core gets a request that follows this pattern, it will take whatever the last value of this route is and set that as the ID for the action that gets called. And when this method executes, we just want to pass that ID into our product repository and ask it to give us the product that matches that particular ID. So we'll say product is equal to product repository dot get product, and we'll pass the ID in. Now there's a couple cases here that we need to make sure that we're protecting against. Case number 1 is product is equal to null, meaning, and this will depend based off your implementation of your repository or your service. But what if I pass in a product that doesn't physically exist in our data store? Well, you can't just return an error or an exception. You need to make sure you return the proper HTTP status code. So we'll do that check. If product is equal to null, we're going to return a not found, or a 404. But if product isn't null, meaning it has a value, we can just return that value as a 200 OK. Let's walk through this example in Postman and see what happens. Over in Postman, I've already made the initial request to products that returns the list of products that I currently have. And notice my only product in here has the ID of 0. If I were to change my URL to products/0 and hit send, ASP.NET Core will send that call to my getProductById action, and it will only return the one product. But what happens if I try to send in a product ID that does not exist? And we protected against this, but let's see it in action. Hitting send to product/5, which does not exist, returns a 404 not bound, which is the proper response type in this particular case. And let's explore some of the other constraints that we can put on these IDs. For example, I know that the ID coming into my application is going to be a long. It's going to be a big int. So we'll set the parameter type to long. I'm going to go ahead and set a breakpoint on line 24, which is the first entry into our application. I'll go back in the Postman and we'll rerun our original request to product/0 and see that the ID is properly being filled out with the value that we're expecting because it's of type long. But what if I go into Postman and type in ABC? Now this would still, originally in our previous example, resonate as a valid request. The problem is that ABC will not convert into a long when type conversion occurs. So what happens in this case? We notice it returns 404 not found immediately. My code didn't even execute, didn't hit the breakpoint. That's because ASP.NET Core stepped in at the beginning, noticed that even though that it saw something that resembled this pattern, it didn't resemble it enough where it could convert the ID into a long. So it just returned a 404. That particular request could not be found. Let's take this a step farther. Instead of just a long, let's add a minimum to it of 0 and a max ID of 100. We'll jump back into Postman and I'm going to type in 0 again because we want to see the original example working. My breakpoint hits and ID is equal to 0. Everything's good. We'll try an ID of 99, which is also good. It still hits that breakpoint. We can see ID is equal to 99, but this ID doesn't exist, so it returns a 404. We'll go ahead and add a 1 to the number, so 199. Hit send, returns a 404 immediately because we have fallen out of that range. It's not between 1 and 100, so 404 gets sent back in its place. Now at this point, we have a perfectly good basic API. We can return a list of products. We can return a particular product if we know the ID, and then we can also create a product if that's necessary. But one thing that's kind of bugging me, and might bug you as well, is that we are repeating ourselves in several places of these actions by using the words products to identify our route. So let's set up nested route options or a route prefix. At the top of my controller, I'm going to add the route attribute and just type in /products. Another note is you don't really need to put the slash at the beginning. You could just say products. It does the same thing. ASP.NET Core can figure it out. But once I've set that prefix, any route inside of this class can just simply be an empty string. For the getProductById, I just need to pass in the ID. And then for createProduct, again, I can use an empty string. ASP.NET Core is going to take the route prefix and add it to the beginning of any routes inside of this controller. This saves you a little bit of typing in the long run, especially as you start adding more and more methods to your controllers. But it gives you a lot of flexibility over some of the initial repeated parts of the URL. We'll show you in this action one more time just to show you everything still works. We'll rerun our original example one last time and hit send. We've hit our breakpoint and everything's good. In this module, we dove deep into the ideas that go into designing a URL structure that will work for your APIs moving forward. The goal of any URL structure is to help identify the intent of the user. ASP.NET Core offers two approaches for defining routes: convention and configuration. For APIs, we tend to lean towards configuration-based approaches as they're more flexible. And as we start defining our routes, ASP.NET Core offers a variety of tools that help us ensure we're building constrained routes that answer when we expect them to. Thanks for listening to the routing module, part of the Building APIs with ASP.NET Core course. My name is Kevin Griffin.